So let's think about this. First of all, can anybody give me any suggestions for what they think u plus v means from a geometric perspective? Okay, so u is just moved 3 steps across and then 7 steps up. V is moved 6 steps across and 3 steps down. What would u plus v mean from a geometric perspective?
Adding the few steps up and a few steps down, or just like x plus x and y plus x plus y plus y.
Yeah, good. So you just simply add the components together. Good. But what does adding mean from the perspective of vectors? Anybody got any ideas? Okay. Think about it. If u means, I can literally draw this out. So let me do u in red. If u means move 3 steps across and 7 steps up. Okay. So that's my vector u. Okay. 3 steps across and 7 steps up. Okay. Now v, let me do this one in red, blue, means move 6 steps across and then 3 steps down. Okay. Now I'm going to suggest to you, we've moved along u and then we're going to move along v. Let's see what happens. Okay. So I'm here, now I'm going to move along v. So I've moved along u, now I'm going to move along v. So I move 6 steps across and 3 steps down. Okay, so 6 steps across, 3 steps down, which means that now I finish over here. Okay. So if you like, what I've literally done here is moved from here to here. Yeah? So if I connect that together with a straight line, what do you think that black vector is going to be?
U plus v.
Good. How many steps have I moved across?
5, I don't know.
Yeah, you do. I've moved 3 steps across and then another 6 steps across when I did v. So I've moved 9 across. Good. Yeah? How many steps have I moved up or down? 4, because I moved 7 steps up, then I moved 3 steps down, which means in total I've only moved 4 steps up. Okay? Now just check it. U plus v, well, u is 3, 7. V is 6, negative 3. If I add the components together, what do I get? What's 3 plus 6?
9.
And then if I add 7 to negative 3,
4.
good. Does that make sense? So it's the same kind of idea. So if I add 2 vectors together from a geometric perspective, what I'm literally doing is moving along one vector, then moving along another. Okay? But you're happy you can just treat the component directions separately. So the tops, then the bottoms. All good? Okay, good. What about 2u then? What do you reckon that's going to be?
6, 14.
Good. It's literally just 2 lots of u. So twice the length in the x direction, so 6, and twice the length in the y direction, so 14. Make sense?
Yeah.
Yeah? Okay. What about the modulus of u? What about the distance along u? Good. So I'm taking the square root of 3 squared plus 4 plus 7 squared. Is that okay? And what do we get, sorry?
58.
Square root of 58? Okay, good. All good? Right? Now this one takes a little bit more work, right? But it's not that difficult, okay? First of all, do v minus 3u. So take v, which is 6, negative 3, okay? And I take away 3 lots of u. So I take away 3 lots of 3, 7. Okay? Then I take the modulus of that. So first of all, what vector am I using? What's 6 take away 3 lots of 3?
We multiplied 3 by 3 and 7 first.
Yeah, good.
So minus 9 is 21.
Good. So I'm taking away 9 and 21, right? So what vector do I end up with?
Minus 3, negative 3, and
Good.
Negative 24.
Good. Okay, so that's my vector, and I need to take the modulus of it. How do I take the modulus of a vector?
The Pythagoras theorem.
Good, so I just simply square root negative 3 squared plus negative 24 squared. I've made a mistake. Where's my mistake? So I've made a mistake deliberately. What's the mistake I made?
We don't have to write the minus.
You don't have to write the minus, but if I did want to write the minus, how would I do it?
The square root of the brackets.
I must put them in brackets because I want to square the entirety of negative 3. Whereas this would just mean do 24 squared, then take it negative, which is clearly wrong. Okay? So always put it in brackets if you need to. Did we get an answer for this? Just give it to me as an exact form.
3 square root is 65.
3 square root 65. There you go. Is that okay?
Oh wait. Square root of 3 squared
Yep.
plus 24.
Yeah.
It's correct.
Good. 3 square root 25. 65. Is this okay? Are there any questions with this? Okay. If one of these came up in the exam, what do you reckon? Yeah? No?
Easy.
Easy, right? Okay. Now, I'm sorry to say, it does get a little bit harder.
It doesn't come like this in exam?
Yeah, absolutely. You can get a question like this. Absolutely. Get faced with a question like this, right? First of all, I just want to make you aware there is another way which I could write these vectors, okay? So we usually write them as column vectors, and in this course you generally see them as written as column vectors, but very occasionally you'll see them written in a slightly different way, okay? Let's just take the u first of all. Now, u is 3, 7. How would you think of this? So if I gave you 3, 7, what would you literally be thinking? If I asked you to draw the vector u, what would you be thinking?
Points 3 and 7.
Good, so it's saying 3 steps across. Oops, 3 steps across. So 3 steps to the right. And 7 steps up, right? Yeah? Okay. Now, you're literally already thinking of this in terms of steps. Okay? So why not, instead of saying steps to the right, why don't I write that as one vector? Okay, so a step to the right. Why don't I actually give that a name? Why don't I call that, so one step to the right, why don't I call that vector I? Yeah? So vector I is just simply one step across and no steps up. Does that make sense? Yeah? Okay, then I've got steps up. Okay, well I've already used I. What letter do you reckon I'm going to use next? J, absolutely. And J is going to be one step up, which is just 0, 1. Is that okay? Yeah? So one step to the right would just be I, and one step up would just be J. Okay? If I wanted to also talk in the third dimension as well, so forwards and backwards, what do you reckon the next letter is going to be? K, right? And K would be one step outwards. Well, so far I'm talking in 2 dimensions, yeah? Left and right, up and down. If I wanted forwards and backwards, just stick an extra 1 on the bottom here. So in other words, this would be 0, 0, 1, like that. We tend not to use K so much, okay? But just be aware of it. So if I wanted to rewrite U in terms of I and J, so at the moment it says 3 steps to the right. So how many lots of I am I going to be moving along?
3.
Yeah. So it's going to be 3 lots of I. And then, so I'm going to be adding them, I want to move 7 steps up. So how many lots of J am I going to be moving? Are you happy that's a completely equivalent way of writing U? Does that make sense? Yeah? Okay, what about the other vector? What about V? What about V? How would I write that in terms of I and J? 6i, because I move 6 steps up. Sorry, 6 steps to the right. Good, because I move 3 steps down. Okay? So the negative tells me I move J in the opposite direction. Is that okay? So a completely equivalent way of writing these vectors is using I, J, and K. Okay? So if you start seeing I, J's, and K's going on, don't worry, don't panic. It's still exactly the same thing we were doing before. It's just they've written it slightly differently. And in fact, what I would encourage you to do, if you see I, J's, and K's going on, convert them back into column vector notation. It's easier, right? It's easier to see what's going on. Happy with that? Okay, good. Good. So what do we get for part 1? How do you convert this into IJK notation for me? Perfect. What about part 2?
3i plus 7j plus 9k.
Good. Oh, 7j plus 9k. Good. What about this one back into column vectors?
6 minus 2.
Hard? No, absolutely. Always work with it in this form because you're less likely to make mistakes, but you need to be aware of how to convert between the two. All good? Happy? Perfect.